Right, greetings all. Hope this finds you well as always. It's now time for the latest update from the machine shop, where we're up to and what we're on with. And what I'm on with is having a go at our store. To be brutally honest, we've got a bit of spare time at the moment, and this store, the Fort Pardy as it's known, has been in a bit of a mess for a while. To be brutally honest, simply haven't had the time to get on top of it and bottom it properly as it needs. So now is the time, and yeah, we're having a sort, and we find all sorts of weird and wonderful things, some of which I didn't know we had. Like, for a start, we have one of these. Anyone know what it is? Go on, don't all shout at once. For those who are curious, it's an Elco meter. What, I hear you cry, is an Elco meter? It's for measuring the thickness of a paint film, of course. No, I didn't even know such a thing existed either. We've also got this little beast here, which is a very nice piece of glass. Lovely, it is. Beautiful little thing. That's an optical flat. That's for measuring the flatness of a surface. Basically, you place that on the surface, ring it to the surface, shine shine polarized light on it, and you'll see a series of it's actually, let me get this right, it's the light and dark bands that are formed from the constructive destructive interference of the light waves. There you go. Yeah, I had to read it all up on Wikipedia as well, so don't worry about it. Anyway, basically, those, by measuring the distance between those, it can tell you to a stunningly high degree, and we're talking millionths of a micron, we're talking fractions of a micron here. It will tell you how flat the surface is. As you can tell, it's clearly been fished out of that box and used every day as well. So that's something else that I've found. We've also found some stuff that I genuinely, despite my best efforts, both me and Google, and 4 people who have spent considerably longer doing this game than I have, can't even identify. So there you go. So that's the bit I've been on with. So I'll go and have a look at some of the other stuff that's been happening. Right, and here we've got the latest progress on Barry's gear cutting, where, as you can see, we've got a gear wheel. And naturally, it fits with a worm. Now, what Barry's done here is, when we last saw this, he was roughing out the gear tooth profile. What he's now done, if we look at these, we can see how he's machined the finished form of the profile, and he's also put some clearance in here. Now, this is something that, until I was talking to him recently, it didn't actually occur to me. If we look at the gear teeth engaging with the worm here, if we look at the teeth there, where the two are absolutely square to each other, they're mating fine, they're mating perfectly. But let's look at the teeth here and the teeth there. As you can see, they need some clearance on their flanks to actually engage and disengage with the worm. If that worm was winding itself along a rack, along a straight gear, if you will, it'd be absolutely fine. But because it's winding a curved gear, it's engaging with a curved gear, it's got to have that clearance. Now, I've just been talking to Barry about this, so I just thought I'd just take 2 minutes to show some of the tools the clever old devil's been using, and has also been kind enough to leave out and share with me. Right, first of all, this is his roughing cutter. And so what we saw last week was there's a series of slots around the periphery of this gear. He was using this cutter as a fly cutter, and he was cutting out the bottom of that, well, I don't know what to call it actually. I'm going to have to learn the words for this. We'll call it a gullet, for want of a better word. He's cutting out the base of that profile, so we end up with a series of slots around the periphery. The next job he did was he's taken another tool. He's made these himself, incidentally, brazing carbide tips onto steel tool shanks. He's taken this tool, which, if we offer up, we can see has cut the gear profile, now minus the clearance. This tool was ground to be a match for the profile of the worm, and so he cut this, he used this to cut it without any clearance at all, but you can see this clearance has been added. Now, what he's done there to get that clearance, first of all, he's varied the centre height, because remember, this thing's vertical on the rotary table, so he's varied the centre height by moving the tool up and down vertically. He started to put some clearance in. And then the second thing he did, and he freely admits, and has just said it to me right here and now, this is actually more trial and error, was what he also started to do was vary the indexing of the gear. So effectively indexing it slightly further. So instead of cutting on the centre line of the tooth profile, what I actually started to do was cut on the flank here, so to put more of that clearance in there. And he quite cheerfully admits to me that that was a trial and error process. And well, I think we can quite safely say it may very well have been trial and error, but it's certainly produced very impressive and very effective results. This does wind over on the worm. It's just a bit stiff at the moment because it just needs to bed in, basically. But he's got this all reassembled. There's a bushing in the bottom here that this all locates onto. This retaining collar here then holds the gear onto that bushing, and then this key here goes through this shaft, this whatever we'll call it, bushing for want of a better word, the gear sits on, engages with the key slot in the gear, and then also the boring bar it goes through this hole in the middle of here and engages that keyway there. So when this drives, that drives, that drives, that drives, the boring bar goes round and does its stuff. So the next thing Barry wants to do next week is put the motor onto this and gently turn it over by hand and, well, turn it over slowly under power. Just check there's no tight spots, check there's nothing binding. You can see there's Mike Blue on that gear. He's already wound it all the way around by hand and hasn't found anything horrific or any major rub points. So his next plan is to set it up to run it over by power and see where it goes. But I'm certain, well, impressed isn't the right word. I'm blown away with this. This has been a very instructive and educational experience for me. And I'm very grateful to Barry for the opportunity to ask him 301 stupid questions and, yeah, see where it went, because it certainly produced results. That's excellent. And if we look at the remains of the old gear behind it, we can certainly see, and no, I am not exaggerating, that is what we were running with before. We can certainly see he's definitely made an improvement. That thing on top, incidentally, is the dummy shaft he made. That shaft, this middle diameter here, is machined to the core diameter of the worm, and he used that to ensure that the radius here and also the diameter, the outer diameter of the gear, would match the worm shaft when it was all put back together again, if you're wondering what that was for. So there we go, folks. Results have very definitely been had, and I hope you found the following this little challenge as educational as I have, because I've certainly learned an incredible amount off Barry whilst watching him do this. Right, another job request that's come in is, for a bit of variety, is Permanent Way Department want a batch of these. These are the door pins out of the plate wagons that they use for ferrying everything from sleepers to rail to ballast to whatever about. And they've basically a lot of them have got to the stage where they're worn out. And so they've requested not one, not two, but 50 of them of us, which isn't a problem. Straightforward turning job. The only problem is we do need to get some material, and we do need to start thinking what it is and what we're going to do. Right, well, the first thing I did was I had to identify the material. I'm sure some smart Alex is going to say steel. Yeah, it is steel. Well done, 10 out of 10. What type of steel is it? Well, to do that, we use what we call a spark test. If you look closely, you'll be able to see on the end of this little teeny tiny bright spot there. Right, well, what I do is I very carefully, that's been very carefully ground with a grinding wheel, and I've observed the sparks that come off the grinding wheel very closely, and certain different grades of steel, because steel isn't just steel, you've got high carbon, low carbon, chrome, molybdenum, and so on and so forth, high tensiles. The spark pattern you get from all those different grades of steel are subtly different. And so I look at it and say, right, those sparks look suspiciously like the sparks you get off Common Garden mild steel. To me, they're not the sparks you get off high tensile, which is what I thought it might be. And so at which point I probably go to the rack, fish out a piece of mild steel, and simply spark the two alongside each other. And surprise, surprise, the sparks are absolutely identical. So bingo, we know it's EM3. Right, next challenge. How much do we need? Well, these pins, I'm going to propose we make them in the traditional fashion, that is head to head. So you simply cut a billet and then so it'll be twice that length, and you make 2 pins out of that. You then chop it in half, bingo, you got your pins. So our billet length is that length, well, twice the length of the pin, plus 1/8 of an inch to part them off. So we'll just come to the figuring here. So each pin is 3 3/4 inches. We add 1/8 of an inch onto that. That goes to there, and if you work it all the way through, we can see that we need 16 foot 2 3/4 inches of material, which is EN3, which is 1 3/8 diameter, and so that order's gone in with Wilson Steel to get that ordered. So that's just one job that's going to come up. The next job is Eric. For those who don't know, Eric's been stopped, needs some axle box work, and the decision's been made to do a lot of the motion work. Now this, I hasten to add, this is my preliminary guesstimate of the work that needs doing. From simply going round and jiggling the small motion, plus experience having dealt with Eric before, it needs most, if not all, the small motion bushes doing, quite a few other pins. The big ends have definitely been working on the crank pin, maybe loosen the rod. We want to check the intermediates, and I happen to know the trailing bushes need doing. So that's the job list. So the next challenge is to work out what material we need, and that, ladies and gentlemen, that scribble there is the most effective way of spending somewhere in the region of a couple £100 with William Lanes that's available. So when we work it all through, material required, 4 billets of 2.5 inch, 1 billet of 3 3/4 by 2 1/4, and then we also need a quantity of EN16 for the pins. The EN16 we haven't stock on the rack. I've checked, there's a full length of that, so we should be okay for the steel. So that's the bronze we will need to sort out Eric. Now, there may be other stuff on that. That is just the first guesstimate. So, but there you go. That's lining up the next job and keeping Brian and all the rest of them nicely busy, as they should be. So, anyway, folks, I hope you found this the usual interesting and educational, informative as always. Now, take care, and I'll see you around.